Good day and welcome to Calculus in the PM. I'm your host, Mr. Sandalka. And first, a message from our sponsor, the Old Sears Bargain Center. And it's back. Yesterday we saw Dominion. Today, Woolco is returned too. Dominion and Woolco, when I was a kid 35 years ago, used to be across the street from each other in the North End. Returned to Regina. Check out our massive discounts on men's fashion, skateboards, leg hold traps, etc. You look at that, eh? Look at this guy. Good? You see?
Who's that?
Who is that? I know who it is. Yeah. And once again, like I said,
It's like I can't see it.
Ponderosa Bonanza and other skateboard tricks. Anyways, you guys remember Woolco? Some of you? No. You guys? Oh man. That's.
I don't think we existed.
I know.
Sears.
Yeah, Woolco might have been 15 years ago. Simpson Sears used to be called Simpson Sears before that. Anyways, you guys know nothing. All these old stores. OK Economy, I don't know it. Okay, go down there right after school and you'll see what Woolco is all about. So back to here. So I say instead of using this formula, write out the inverse, take the natural log of both sides, then differentiate. Well, just pausing. It's probably a salesperson. Okay, guys, back to this here. So the whole idea is where does that come from? If I said that, now normally logs other than E base. Now I don't, if I just do this, we're assuming this is log base 10. I'll put the 10 in there, but you don't normally do that, right? Now, if this is the log, natural log of x, we know it's just 1 over x, right? This isn't though. Now there's a base change formula, and I alluded to that the first day, and I brought it up again. Apply this base change formula. Well, that's great if you remember this, and you guys said you hadn't used it before, and typically students don't in their pre-calc in Saskatchewan. So where does this base change thing come from? Well, if you don't know this base change formula, and I say this on the little sheet there, I say, instead of using the formula here, if you don't have it memorized, write the inverse and take the natural log of both sides, then differentiate. That's how you base change. Okay, I said a mouthful, unless you see this here. How do we do a base change? Well, the inverse function of a log function is an exponent, right? So, what's the same information given as an exponent? 10 to the what? Equals x. Okay. Take the natural log of both sides. Now, I'm going to purposefully just do this. Now, the reason why I wanted this, it got stuck. And you'll see. I want to move this in a second here. Why? Because when you have an exponent inside a log, what can you do? Right? Yes, I see. Okay. I do that automatically, but I want to show you. I don't want to befuddle you if you didn't think about this. Now, natural log of 10 is a constant, isn't it? It's no different than dealing with 3 or 17 or whatever, right? Pi squared. Just keep, that's, so this is not a function really, right? So really what we have, or I mean, it's a constant. Okay. So really what we have here is, from the blue here, I base changed it. Y is equal to the natural log of x, and I isolate for this, natural log of 10. You guys agree? Now, if you get good at this, I can usually do this in my head. I actually don't have the base change formula memorized. But I do this, it is the base change formula. I can do this, and I'm convinced that I know what I'm talking about. Now I'm just going to flip back That base change formula is the log of whatever base. You just take the log of the inside, the x, and the log of the base. That's what that base change formula is. But I've never needed, as long as you understand what logs are and exponents are, you shouldn't need it. You could change the base. Now, question.
Does the formula say this?
That's what this formula, yes, that formula is what I just did in blue.
That's long. That's how
Yep, it doesn't matter what base you're using. Change though, because you can do calculus better with log base e, natural log. So change it to the natural log. Once you have this, you know how to do calculus, right? I think you do. Now, I wouldn't recommend rewriting this, but just think of this as some number, natural log of 10, right? This would be like a 5 in front of it or something like this. Natural log of x. Would you agree that this is the same expression here? Agreed? Now, I'm only doing this, I would not normally rewrite this. But once I do this, this is no different than having a 5 in front. It's just somehow sometimes the natural log itself screws people up. So, that's just a multiplier, it's left in front. What's the derivative of the natural log of x? 1 over x. So this is, now I'm going to do this as two separate chunks. I normally, now, and then the derivative of the inside if you need it, but that's 1. But question. But this is a constant, right? It's a number. Oh, don't apply, I see what you're doing. If I had this, if I had y is equal to 5x squared, what would you do? You'd tell me dy by dx is equal to, oh, and you know what I forgot? I saved dy by dx and I forgot that I was doing that here. Oh, there's a reason why I didn't put it there, because that's not true. Sorry, right here. Okay, I'm trying to do two things at once, but I'm getting scattered. Okay, here though, you would say 5 times 2x. You'd do it without thinking, say 10x, right? The number in front, you could apply the product rule, but it's a constant. So then you'd have 0 times x squared plus 5 times the derivative of x squared. This is a constant. It's no different than that 5 in front. Just say it multiplies by whatever the derivative is. It's just getting used to, and I keep throwing these at you, right? E to the 5, cosine of pi thirds. They're constants, right? Just treat them as numbers. Okay. Now, I'm just trying to convince you that it isn't really that much work. You could memorize this formula, and I'm not saying you shouldn't. I don't recommend it because there's going to be too many things to fill your head up with anyways. Okay? So, knowing this, differentiate the log base 5, where was it? Y equals the log base 5 x to the, I'm going to purposefully wait here until 1/2. Okay. Now, I've worked this out in the previous problem. I realize when I have a different base, because once you do one, you can see it for the others here, right? It just turns into, like we had here, 1 over x times the base on the denominator, right? The natural log of the base on the denominator. That's what we had with the 10, right? Question or stretch? Stretch. Okay, the 10. And a yawn. Okay. Anyways, so what should we do here? Well, first thing I'm going to do is move this, because it's inside a log. And I'm going to move it out and rewrite that with that in front. So if you want to just scratch it and move it in front, do that. It makes your life easier. Otherwise, you've got the chain rule inside there, and it makes your life a nightmare. Not a nightmare. Okay. Question?
equal to ln x over ln 5.
That's exactly my next step. Okay. Y is equal to, I'm going to put the 1/2 in front. And then I say, it's the natural log of the x over the natural log of the 5. That's the base change formula, which we talked about on the previous page,
The
right?
formula on the top. is
That's the
log.
formula on the top.
So that's log. It doesn't matter if it's.
It doesn't matter what log base it is.
No, because yeah, it's.
It
log.
doesn't matter ln, log, log base 17, anything. A log is a log is a log.
So why does the base of the log go to the bottom and the
Yep.
x go to the top?
Good. The reason why, now I forget what the base of this one was, 5 was it? Okay. If this was 5, same explanation here, but we're using 10, okay? But it looks very similar. If you just rewrote this as, in this case, 5 instead of 10 there, to the y, okay? Take the log of both sides and isolate, it becomes this. And that is, in a nutshell, the base change formula. I honestly do sit and think, I have about a 3 or 4 second delay, and I just write this, I go directly into this, but I actually do mentally check this. The first time I do it if I haven't done it for 3 or 4 months. After I do this several times, it gets locked in my brain again, but I've never worked on having it in long-term memory. Okay, that means I now have it ready. I can do the derivative. And the only thing in here that's a function of x is this part. The rest are constants, right? It's really 1 over 2 natural log 5 as the constant. So I'm going to just write that out. So I'm going to call this y prime just for something different. I usually use dy by dx. So 1 over 2 natural log 5. That's the constant that's in front of it. And then I'm going to do the actual derivative. The natural log of x is 1 over x.
Can you do also the quotient rule?
Do not do the quotient rule because these are constants. There's no x's on the denominator. Constants, just treat them as numbers. Yeah. Oh, I thought you were going to ask me what my favorite color was. Okay. Clear. Colorless. I'm colorblind. I don't know. Those were my school colors, actually. Colorless. Clear and colorless. We show up in saran wrap and stuff like that. Anyways, one other thing. Sometimes the properties of logs can be used to simplify. Hey, guys. The differentiation process, even if logs themselves must be introduced into the process. Now, if you're doing that to simplify something, we call it logarithmic differentiation. There's one on the assignment that I haven't even got through the first page with you guys, the correcting that you gave me. So I had it back, but there's one that's along these lines. If you have something, and I think on the assignment it's something like this, x with x squared, and it's one of the pages I haven't assigned yet. You will do it when you get it back. Something like this. Well, the minute you see an x in the exponent, think I'd better take logs. Okay? So, logarithmic differentiation. Take the log of both sides. Y equals x and then cos of x in the exponent. We'll call this the natural log of y equals, now I'm going to leave some space in front of here. The natural log of x, and then the exponent right now is cos of x. Why did I leave that space in front of there? Because I'm going to do the old swinger, right? There you go. Move that out in front. It makes it way easier, and the whole purpose was to get rid of the exponent with an x in it. That's why we use logs. Now, once you do this, you can use implicit differentiation, right? Yep.
What do you do? Product rule on the other side?
And we will use the product rule as well. We're going to do it right now. So the left side, we're doing d by dx on everything because we want dy by dx. So keep this in mind. By the way, if I ask for dx by dy, do you see that you treat the x's as the black sheep and you'd have dx by dy? It would just be the opposite way of thinking, right? Anyways, we want d by dx. d by dx of this, 1 over y, right? Because it's really applying the chain rule to this. That's the outer function. But it's a mismatch, so when you take the derivative of the inside of the y, it is, you say, I don't know, it's dy by dx. Then, as mentioned, we've got to use a product rule, because it's the cosine function times the natural log function, with x's inside. So the derivative of the cosine function, negative sign. And I could tell you that 80–90% of your stuff, even on an AP exam, the stuff without a calculator, will be sines and cosines. The odd time you get the other functions, but not very often. So negative sine of x times the other part left alone, plus the cosine of x, so the first thing left alone, the derivative of natural log 1 over x. Now I haven't quite finished this, have I? I need to isolate for dy by dx. Yeah, multiply y. By the way, what the devil is y? Y is equal to this expression. Or no, sorry. That's a no, sorry, I circled the wrong thing. Y is equal to this. I was just blindly, and then I looked after I circled it. Y is equal to that expression. So when I bring this up, I'm going to multiply that whole side by y, but I'm not going to write it as y. I want it as a function of x if possible. So I'm going to put x cos x. I'll do it as 2 steps, just in case you don't. If you want to jump right into the answer, go ahead. I'm not going to do any real simplification in here. Sine of x, natural log of x. I'm just making it shorter by, say, cosine of x over x. But then the y, what does that represent? That represents the original function.
Oh, we don't have to actually multiply it out or anything?
Don't bother, unless I tell you that you can simplify it or something like that.
That's what I was.
Don't simplify. If I say on a question, first step only, don't simplify, don't. Don't waste time doing it, right? Okay. And that's that. I will pause. Emma will do her visit.